So we found that 2 seconds is a good trade-off in computation time, because this lets us stay real time, which is obviously important, and accuracy. Okay, so just a quick recap of what exactly is going on. We collect the sweeps data that I described earlier to build a baseline dynamics model. Our expert pilot demonstrates the airshow several times. We learn a target trajectory using the algorithm I described earlier. We learn a dynamics model using the other algorithm I described earlier. And this is the local dynamics model, right? This isn't the baseline now. This is the per-trajectory dynamics model. And then we find the optimal control policy for the learned target dynamics model. This is essentially the RHJDP controller. And then we fly the airshow. And this process, sorry, I'll get to that in a second. After we fly the airshow once, we can actually improve on the performance. And so, as you saw in the demos I showed you earlier, the pilot can't repeat a trajectory perfectly, right? However, when a computer is flying it and it doesn't crash, it can repeat the trajectory fairly well, actually. So once we have a good trajectory that's good enough to fly, it flies the same thing repeatedly. And so it might not look perfect yet, but it'll fly the same thing in the same imperfect way. And what we can do then is learn why it flew imperfectly and update the dynamics model, right? So we had some target trajectory. We flew it using the controller and dynamics model we just estimated, and it didn't work perfectly yet. And then what we're going to do is go back and see why it didn't work and update this. And we're going to iterate that like maybe 2 or 3 times. And in the end, what happens is it takes about an hour to learn a new trajectory. So this whole process, once everything is in place, takes about an hour. Okay, so let's see some results. So the helicopter starts off on the ground, it spins up its blades, it takes off and does this inverted takeoff. And you'll see the first 3 things are kind of the 3 maneuvers I described earlier that previous work has done. So the first 15 seconds shows you what all of the previous success in this area has been, and everything after that is completely new. So there's a split S, there's a snap roll, and here's a stall turn. And what a stall turn is good for is it's a quick way of changing direction. So loops